Hello everyone. In this week, we will discuss about a prominent field of data science called deep learning. Deep learning is a subset of machine learning that employs artificial neural networks with multiple layers to model complex patterns in the data. With each layer of deep neural networks, the model can automatically identify features from the raw input, making it exceptionally powerful for tasks such as image, speech recognition, natural language processing, and more. Deep learning has been behind many of the advances in AI over the past decade, enabling breakthroughs in fields ranging from autonomous vehicles to medical diagnostics. By leveraging large amount of data and powerful computational resources, deep learning models can achieve remarkable accuracy and efficiency, and even surpass human performance on various tasks. So, in this week, we will briefly discuss some important concepts related to deep learning. Let's start. If you know from the previous week, we focused on the traditional machine learning techniques. We discussed two broader categories of machine learning. One is supervised learning. Within that, further we discussed two types of tasks, the regression task and the classification task. We saw algorithms within each category. For example, in classification, we discussed about logistic regression, decision trees, and others. And within unsupervised learning, we primarily focus on the clustering task, and we discuss two algorithms within this category also. In this week, we will focus on these points. We will first discuss what do we mean by deep learning. There are various famous frameworks and model architectures available related to deep learning. We will focus on that. Out of them, these two, CNN stands for convolutional neural network, and RNN stands for recurrent neural network. They are quite famous, and we will see their usage related to these two tasks. One is image classification and the other one is text classification. So, in today's lecture, we will be focusing on the concept of deep learning, why it has become so important in recent days, and how it is different from the traditional machine learning technique. We will be focusing on these three broader topics. So, let's start with deep learning itself. You can see deep learning as a subset of machine learning. However, in the case of deep learning, we use neural networks that we have discussed earlier, but with a lot of layers inside. That's why the name deep, because we use too many layers between input layer and output layer. On the other hand, deep learning is capable of learning from large amount of data, which is not the case with traditional machine learning approaches like logistic regression, decision tree, and others. However, some things are similar. Like traditional artificial neural network, in deep neural networks also, we have artificial neurons, we have layers, we have activation functions, but the type have changed. For example, we have advanced activation functions there and advanced layers. We will focus on these nuances of deep learning soon. Overall, deep learning provides multiple benefits over traditional machine learning approaches. So, it has been identified that in traditional machine learning algorithms, except neural networks, that as the amount of data increase, the models reach to a saturation point in terms of their performance. That is, their performance does not improve anymore. However, in artificial neural networks, we can absorb as much information by increasing the number of layers in it if the available data is huge. This is one of the reasons why deep learning became so useful. So let's understand the underlying process of deep learning. Here also we have layers of connected nodes. So if you remember, in artificial neural networks, we have a structure like this. This is called the input layer. This is called the output layer. And the layers in between, they are called hidden layers. So in deep neural networks also, we follow similar structure. Here also, we use the concept of forward propagation. Means input is supplied at the input layer. It goes through all the hidden layers until it reaches to the output layer. And based on the amount of error here, which means the difference between the predicted value and the actual value, the weights of these edges are adjusted, and this process is called backpropagation. In deep learning neural networks also, we follow the similar process. Often deep learning based neural networks, they are too heavy, and writing the code for them is not very straightforward. For that, we have various famous deep learning libraries, namely TensorFlow, Keras. There is another very famous framework called PyTorch, and others. They simplify the development of deep learning models. So overall, the idea behind the deep neural networks is similar to the traditional neural networks, but with more advanced concepts. Let's try to understand that. We have already seen this diagram in earlier lectures. This represents a typical artificial neural network where you have one input layer, one output layer, and one hidden layer. These are the weights, and this specific thing here represents the neuron with specific activation functions. In deep neural networks, the structure is somewhat similar, but as you can see here, the size is relatively large. Here we have this input layer, and usually input layer contains many neurons, a high number of neurons. Then we have lots of layers in between, and finally we have this output layer. So as you can see here that the structure is somewhat similar. Here also we have connections connected with previous layer with the next layer and so on. Each node here also, by the way, uses certain activation function. So things are similar, but the type of activation functions used, the types of layer that we have, these things have changed in the era of deep learning. Now, what are some of the major applications of deep learning? It has been identified that deep learning is specifically useful in domains where identifying the pattern is much more complex. These are some of the applications. In the field of computer vision, deep learning models, particularly CNNs, convolutional neural networks, have become foundational, and they are used for the tasks such as image recognition, object detection, and video analysis. Another major domain is speech recognition and generation. Speech recognition and generation is another field which is affected with the advent of deep learning. Deep learning has significantly improved the accuracy of speech recognition systems, leading to the widespread use of virtual assistants. You might have heard about them like Siri, Alexa, and Google Assistant. Natural language processing is yet another important domain. Deep learning techniques, including recurrent neural networks and transformers, have advanced the state of the art in language understanding, language generation, machine translation, summarization, and others. Also, deep learning is at the heart of self-driving technology. In it, it processes data from multiple sensors and cameras to make decisions in real time about navigation, obstacle avoidance, and traffic understanding. Moreover, advanced deep learning models are being used to personalize content recommendation for various tasks such as streaming, shopping, social networking platforms by analyzing vast amounts of user interaction data. So you can see that these fields require complex pattern recognition, and that's why they resort to deep learning models for the betterment of the field. Now let's talk about the difference between machine learning and deep learning. There could be many ways in which we can differentiate between them. One of them is what is at the core of the difference between these two paradigms. If we talk about data handling, traditional machine learning works well with structured data, whereas deep learning excels with unstructured data. So when we say that the data is structured or unstructured, we primarily refer to the fact that in traditional machine learning, we used to have data like this, where it was very neat and clean and arranged in a tabular format. And in the case of supervised learning, you might have a y value. This kind of arrangement of data is referred as structured data. On the other hand, unstructured data is, let's say, when we fetch data from social media platforms for further analysis, maybe based on some news that has been published on social media platforms. We want to identify whether that news is fake news or it is a real news. Now that data is a textual data and it is not arranged neatly in this structured format. So for those tasks where the data is unstructured, let's say speech, and we want to generate text from the speech. Now speech by itself is unstructured in nature. So for those tasks, traditional machine learning, I would say, are not very useful, but deep learning techniques are certainly useful. Another major difference which lies at the core at both the paradigms is the feature engineering. In traditional machine learning, feature extraction requires domain expertise, where deep learning automates this process. Now, what do we mean by that is, when we were in the era of machine learning, we used to create the features from the given data, input data, and used to arrange it in a structured form like this. For example, in traditional speech recognition systems, you will find that the speech was divided into words, words were divided into phonemes, and those are considered the independent variables. On the basis of that, you want to predict something. So it seems a bit artificial, because you are considering each word, and for each word you are considering what are the different phonemes it is made up of. It is more like how we think about the speech. But it was a kind of artificial fitting of the data. Deep learning does not do that. It usually takes the whole speech, or we say the raw data, identify the relevant features by itself, layer by layer, and then does the prediction or does the further processing. Another major difference is by the complexity. Obviously, deep learning models are more complex, but they become more efficient as data volume increases unlike many traditional machine learning models. How does the training takes place is another major difference between machine learning and deep learning. If we talk about their model architectures, traditional machine learning uses simpler models, while deep learning employs complex neural networks. The processing power and data requirements are also different for both of them. Deep learning requires significantly more computational power and larger data sets in comparison to the traditional machine learning. When we talk about learning process, machine learning often involves explicit programming of rules, whereas deep learning models learn implicit rules from data. Accuracy is another major indicator or difference between both the paradigms. Deep learning models generally improve as they process more data and surpass traditional models in tasks like image and speech recognition. So these are some of the points on which we can differentiate between machine learning and deep learning, but there are more. What are the difference between these two paradigms based on the practical implications? Deep learning derives advancements in AI fields like autonomous vehicles and real-time language translation. Performance-wise, deep learning models often outperform traditional machine learning models for accuracy and reliability. Deep learning models require more data, computational resources, and development time compared to traditional machine learning. And the last part is quite important, which is called the interpretability, or in other words, explainability. Explainability or explainable artificial intelligence has become a key point of concern in today's time. What do we mean by explainable AI? In explainable AI, the consideration is that can we discuss or rather describe the process of reaching to a conclusion using deep neural networks. That is, when we get the output, can we know for sure what is the inference or the rules that have been used in order to reach to this conclusion? Or in other words, can you explain the process of reaching to a conclusion? Often, machine learning models, especially deep learning models, they are considered black boxes. So when we say black box, it means that the network or the model takes some input and gives us the output, but does not necessarily tell how it reached to this output. So this is considered a black box. But recently there has been a discussion on we should focus more on the explainability part of these networks rather than simply focusing on the output. So in general, traditional machine learning models are often more explainable. However, deep learning models are not. Another major difference between machine learning and deep learning is about the number of hyperparameters. And specifically these hyperparameters. So in traditional machine learning, if you remember, in artificial neural network, we used to have hyperparameters like what is the learning rate, how many hidden layers are required, and many more. In the era of deep learning, we have all these hyperparameters plus some extra parameters as well. Some of them are mentioned here. So by type of layers, we mean that depending upon the application, the choice of layer types affects the model's performance. So we have layers like convolutional layer, we have layers like pooling layers, and there are other types of layers as well. In traditional machine learning, in traditional neural network, we used to have simple hidden layers which look like the input layer, which takes data from the input and forwards the processed part with the help of activation function to the next hidden layer if available. But in the case of deep learning, we have different types of hidden layers. We also have different types of activation function. In traditional machine learning, we used to have sigmoidal 10H activation functions. In deep learning, one activation function is very famous called ReLU activation function. We also have the concept of batch size. So for example, the number of training examples used in one iteration of model updates is called the batch size, and it can influence the training speed and stability. We also have the concept of optimizer or optimization algorithm. Traditional machine learning used to have optimizer like stochastic gradient descent, but in deep learning we have optimizers like ADAM, RMS-prop, and others. They affect how the weights of the neural networks are calculated. Apart from that, we also have the dropout rate, which is a regularization technique. It helps the neural network to not to do the overfitting and generalize well for unseen data as well. Apart from these hyperparameters, we also have normalization techniques like batch normalization, layer normalization, and others which help to accelerate training and stabilize the convergence. So overall, deep learning neural networks have lots of hyperparameters that need to be tuned very specific values in order to have a good performance for a specific task. Now let's compare the machine learning and deep learning. Let's say if we have the task of image classification at hand, where given the image we want to identify whether this image is of a dog or of a cat or of any other model. In traditional machine learning, we used to have to do a lot of feature engineering where we take the input image and convert that into an structured format. In simple words, the XY pair, which can be further supplied to a standard machine learning algorithm. So it takes a lot of effort to take this raw input, which is image in this case, and convert that into a tabular format data. However, in the case of machine learning, this whole image obviously has the pixel values, goes into the neural network, but we need not to stretch this image out as a vector first and then supply that to the model. So overall, we can say that deep learning excels in processing and learning from unstructured data such as images, audio, and text. Unlike traditional methods, deep learning automatically detects and uses relevant features from data. Its ability to recognize patterns and nuances far exceeds that of previous technologies. Deep learning models improve as they consume more data, making them increasingly effective over time. Also, deep learning models are suitable for a wide range of applications, from autonomous driving to personalized medicine. There are some technology related factors also that help develop the deep learning models and improved its performance over time. Advances in GPU technology have drastically reduced the time required to train the complex models. This was not the case earlier. Apart from that, the digital age has produced vast amounts of data. providing the necessary fuel for deep learning algorithms. Deep learning algorithms, they are also called data hungry algorithms. That is, they require a huge amount of data, and in today's world, getting a huge amount of data is possible. Apart from that, enhancements in neural network algorithms have significantly increased the efficiency and effectiveness of deep learning models. There is the concept of cloud computing, and the accessibility of cloud resources has enhanced the use of deep learning. It enables researchers and companies to scale operations. Moreover, we also have a deep learning open source ecosystem, a robust community and frameworks which are open source like TensorFlow, PyTorch have accelerated innovation in deep learning. Now, there are some famous deep learning related architectures. A few of them are mentioned here. Convolutional neural network, or CNN, is primarily used for image and video recognition, image classification, object detection, and more. They learn from low-level features to high-level features. We will discuss them in detail in the next lecture, but they are primarily used for image and video related analysis. On the other hand, we have recurrent neural networks, or RNNs. RNNs are useful for sequential data such as speech, text, and audio. RNNs can process sequences of data by maintaining a memory of previous input through the internal state representations. This makes them ideal for tasks where the sequence and the context of the data are important. However, RNNs can struggle with long-term dependency due to issues like vanishing and exploding gradients. That's why we have more advanced version of RNNs like long short-term memory models and bidirectional long short-term memory networks. Apart from that, transformers are the latest development in this link and have gained popularity in the recent times. They use a mechanism called attention mechanism, which is a complex mathematical operation in the end. But in models like GPT, generative pre-trained transformer, and others, transformers or this architecture or algorithm is being used. GAN, or generative adversarial networks, are another very famous types of deep neural network architectures which have many applications as well. So in summary, in today's lecture, we discuss about what do we mean by deep learning as an advanced form of machine learning. It is used for complex tasks. It is similar to machine learning on many points, but has many differences also. For example, it has a lot of hyperparameters to tune, and there exist many famous deep learning neural network architectures like CNN, like RNN, BiLSTM, LSTM, and others. Thank you.